If cos bracket 2 to power x plus sine bracket 4 to power y equal to 5, find dy dx. Solution. This is an implicit differentiation, so we're going to differentiate both sides of the equation and make dy dx the subject. To differentiate cos bracket 2 to power x, we differentiate 2 to power x. 2 to power x is an exponential differentiation, and from the definition of this, differentiating with respect to x, a to power x, we have a to power x ln a. So now we differentiate this, which becomes 2 to power x ln 2 dots. We now differentiate cos to have minus sine brackets 2 to power x, then the plus sign, again differentiating sine bracket 4 to power y, we differentiate 4 to power y. In this case, we're differentiating with respect to y, so we'll have 4 to power y ln 4 dy dx dots. We now differentiate sine to have cos bracket 4 to power y equal to 5 is a constant, and that becomes 0. Now we have minus 2 to power x ln 2 dot sine bracket 2 to power x plus 4 to power y ln 4 dot cos bracket 4 to power y dy dx equal to 0. Now we're going to transfer this to the right hand side of the equation. We have 4 to power y ln 4 cos bracket 4 to power y dy dx equal to 2 to power x ln 2 dot sine bracket 2 to power x, so that we divide through by this, leaving dy dx the subject on the left hand side. Dy dx equal to 2 to power x ln 2 dot sine bracket 2 to power x all over the whole of this 4 to power y ln 4 cos bracket 4 to power y, and then in this ln 4 can be written as this: ln 4 equal to ln 2 to power 2, and in logarithm this 2 being the power will come down. We have 2 ln 2. In place of this, we're going to write this. We now have that 2 to power x ln 2 dot sine bracket 2 to power x all over 4 to power y. In place of this, we write 2 ln 2 cos bracket 4 to power y, so that ln 2 we cancel ln 2. Therefore, dy dx equal to 2 to power x dot sine bracket 2 to power x all over 2 dot 4 to power y cos bracket 4 to power y. And this is the answer.